So this is the second part of linear equations. Uh, Here we will deal with linear inequalities in two variables, and we will see how to solve the linear programming problem by using linear inequalities. So in this chapter, you will be able to graph linear inequalities in two variables, and you will be able to solve applications of linear inequalities in two variables. In this section, we will learn how to graph linear inequalities into variables and then apply this procedure to practical application problems. So, linear inequalities normally deal with upper and lower half plane or left or right half plane. A line divides the plane into two regions is called half planes. A vertical line divides it into left and right half planes. For example, this vertical line is dividing this coordinate axis into the left half plane and right half plane, and this line is dividing the plane upper half plane and lower half plane. And then we will see later on that which part is our graph of the linear inequalities. This shaded area represents the graph of linear inequalities. So there is a very simple procedure to graph the linear inequalities. You will be given inequalities either in this form, means less than or greater than, and then we will solve them accordingly. For example, our very first step would be we will substitute linear inequality into an equality form. We will write it ax plus by equals to c, and then we will solve it for x or y, whatever function you will be given. So there are three simple steps to graph the linear inequalities. The very first step, as I mentioned earlier in the previous slide, we write inequality in an equality form. We put it equals to equal sign instead of less or greater than 0. Then we choose a test point anywhere in the plane, not on the line. Normally we choose 0 0 because it is easy to calculate. As you can see, you can choose any point anywhere in the plane, but we prefer 0 0 because it gives us less computational work. Does the test point satisfies the original inequality? If so, shade the half plane that contains the test point. For example, I solve example here instantly. Let's say x plus y less than 1. I first step I put it equals to 1. Now I choose step 2, say test point 0 0. So I say that 0 plus 0 equals to 1, and now here what we can say that when you substitute 0 0 into the inequality, 1 is greater than 0, so this half plane, so which means that it is true. So the side which contains the half plane, that would be our solution region. You can see it here. Our first example is to the graph this linear inequality. This is linear inequality. First of all, we write it in an equality form, like y equals to 3 by 4x minus 1. 3 by 4x minus 1. Graph the line. Now we make the graph of this line. If the original inequality is a greater than or less than sign, the graph of the line should be dotted. If we have only less than or greater than form, then we will make its dotted graph, not solid line. We will make its dotted graph. Now because we had less than sign, so we made its graph, and you know how to make the graph of linear inequality. We make its dotted graph. Now we'll choose the test point 0 0. So we choose x0 y0 and substitute into the linear inequality, which was 0 less than 0 minus 1. 0 is less than minus 1. That is not true. So the area, shaded area, would be below because this inequality is not true. It does not satisfy the test point. So the shaded area would be the opposite side of the plane which contains 0 0. So now we have to decide which half plane to shade. The solution set will either be the half plane above the line or the half plane below the line. To determine which half plane to shade, we choose test points that is not on the line. Usually good test point to pick the origin. So we substitute 0, 0 unless the origin happens to lie on the line. We will discuss this thing later in an example. In our case, we can choose the origin as the test point. So if we substitute 0, 0 into this inequality, does it satisfy? No, it does not satisfy. 0 is not less than -1. So in that case, since this is false statements, we shade the region on the side of the line not containing the origin. So here it is the origin, so we will shade the line which does not contain the origin because it didn't satisfy our inequality. So that is the shaded area, which is the solution region for that particular linear inequality. And we can also draw its graph on the graphing calculator. Now we solve this example. Let's say here 3x minus 5y, we put it first of all equals to 15. Now we make its graph. You know how to make the graph. If x is 0, it gives y minus 3, and if I say y is 0, it gives x equals to 5. So I make its graph. Since here we have equality, so we will make a solid line for the graph. X is 0, y is minus 3. So this is the point. When y is 0, x is 5. This is the point. So we will make a solid line. Now test point 0, 0. We put 0, 0 into the inequality. So 0 is greater than equals to 15. So it is false statement. So the region which does not contain origin, that would be our solution region. Here it is 0, 0, upper half plane contains 0, 0. So this is not the solution region for this particular equation inequality. So this is the solution region for this particular inequality. The reason why it does not contain 0, 0 because this statement is false. You can see it here. We make the graph of this line. We make a solid line because here we have equality, and we choose different points to make the graph like we did in linear equation in the first part. And we draw a solid line because here we have equality sign. Now 0, 0 is a test point, therefore we share the region on the side line that does not include the origin. So here you can see that we make a solid line and we make the graph which does not contain the origin. For example, here the inequality 2x greater than 8. So 2x equals to 8, x equals to 4. So here this is the graph of the line. X equals to 4, we choose the test point 0 greater than 8, which is false. So that is our solution region. Here you can see the whole explanation is given in step 1, step 2 and step 3. You can go over and you can see this is the graph of this linear inequality. Similarly, for this equation y equals to, we say y equals to minus 2. Since we have equality sign, we make a solid line y equals to minus 2. Now we want to see that the graph is upper half plane or lower half plane. We put 0, 0 test point. 0 is not less than minus 2, which is also a false statement. So the graph would be the lower half plane which does not contain origin. So this is the explanation which I have just explained. You can go through from it as well. So here is an application problem. A concert promoter wants to book a rock group for a stadium concert. A ticket for admission to the stadium playing field will cost $this, and a ticket for a seat in the stand will cost $6. we say x is the cost for stands and y is the cost for seat, and the total sales guaranteed would be at least means the total cost would be greater than 700,000. So this is the linear inequality, that the total sales will be at least greater than 700,000. 700,000, yeah. So we can divide whole equation by 5. We can 25. So this equation is reduced to this one. We make the graph of this inequality and choose the test point and see which half plane would be the solution region. This is the graph of linear inequality. And one more thing here, in case of real life application problem, there is another condition. We say that x is greater than 0 and y is greater than equals to 0, means x is representing number of tickets, y is representing number of tickets, and number of tickets cannot be negative. We cannot say that we are selling negative 10 tickets or we are selling negative 100 tickets. So in that case x and y cannot be negative, so we put a line that it cannot go into this direction, and we draw a line and it cannot go into this direction because x and y are positive, because they are real numbers, they are representing real items. Now we draw the line and we test the test point 0 0. Again 0 0 does not satisfy our equation, so the solution region would be the opposite side of the plane which contains 0 0.